Yeah, now I can. Yeah.
Oh, David, you did a good job. Okay, so right. Okay, the rule is driver and the navigator can join the live share text editor to do pair programming, and the passengers just watch and follow unless the passenger wanna be the driver or the navigator, so they can join the text editor.
So how do questions work as far as people having questions? Basically, do they kind of wait till after? Do they is it during? Um, is it
Because
just make
this
sure you're not
is
you're
our
quiet?
first session. I don't really know what. If it's just four of us, then we can be casual, you know. If a lot of people, then you know.
I mean, we could be casual. I mean, I'm eating, and my green screen isn't up. You know, it's chilly. It's delicious. So we can be as casual as you want, but yeah, just kind of just so everyone knows what to expect. I guess if I was driving, I'd
Okay,
put the chili down, but well, maybe I would.
you can finish your chili. Maybe we can wait Elizabeth see if she gonna join or not. You know,
But
she said that she would, right?
I believe so.
So I'm gonna see the questions.
Oh, she's typing. Okay, let's see.
Okay, see. I hopefully she can be the driver if nobody gonna be the driver. Gonna be. Let me see. Let me ask her. Okay. Okay.
It's taking a long time.
If nobody gonna be driver, I guess I be the driver.
I mean, it's
You
up to you. I could be the driver. I don't mind.
know, like everybody is passenger, then nobody gonna drive the bus. Okay. Uh, unless I would wanna be the driver to try.
You
Um.
can also take turns if anyone wants to like try to solve a particular part of the problem. It's mostly gonna be talking.
Yeah. Okay. Let me see.
So she's busy. I was about to
You
say, what is she
please
doing?
sorry about trying to finger. So she's not going to join? I don't know.
Yeah, that's the question. I was like, what's going on
Okay, maybe she's not going to join. So we just gonna we just gonna do it. Okay. Um. So here is the thing. Um. So I think maybe we should just start from scratch to start writing this. Then we're gonna run our solution in the platform here and see the automated test.
here? Okay. Oh, yeah. Either whatever works. I was like, so you want to do it there or the editor? Because we can uh test it either way.
Yeah, but my question is, do we need to walk through the thought process, like explanation, the pointer system, all those stuff, or we just go ahead write the answer and run the tests?
Um, I would say we just kind of explain what's needed for the problem in the beginning. As we go along, we don't need to explain everything in the beginning. Just as we kind of come across something, explain it, and if someone has more questions about it, we could go from there.
Okay. Can you do a demo? I don't really know how to start. Uh, oh, I just gonna read the question. Like I
I
don't
can.
know how to start.
I forget. Am I sharing? Is you? Are we all sharing a VS Code? Is it you share?
Right now only
I'm,
you and me.
okay.
Yeah, unless do you wanna join too? Um, but it doesn't really matter. So
But
okay,
yeah, I can explain it. Oh, that's only on my. Oh, that's only on my VS Code. I was like, where's my extensions? Like that's fine. So I could just explain the problem real quick, and then get everyone's input as far as how do you think. What would you do to solve it if you have any ideas?
yeah. You guys can unmute yourself because today only four of us, you know. If a lot of people, we need to do that. You guys can talk whatever you want, you know.
Okay. All
Only
right.
four
Sure.
of us, yeah. Okay, Davian, you can start. Lead
Okay.
us. Yeah.
Okay, sure. So, the problem we're working on now is basically what is it actually called? Um, yeah, it's just the find two sum, and basically the two number sum. That's what it's called. I'm just, like swiping through stuff. So the goal is we have an array, and each number in the array is unique. It's all numbers, and each number in the array is in the array only once. So that's what we mean by unique. And the array can be positive or negative numbers. And the goal is to find at least to find two numbers in the array that match to a given sum. Oh, I was on the wrong. No wonder that's the wrong function name. I copied from the wrong
This one
thing.
is the second question.
Yeah, I was like, I was like, that's no wonder I'm so confused. Okay. So two number sum. So we get an array of integers, and then the number that we want to find, or the target sum that we want to find. And our goal is to create a function to find two numbers and only two numbers that add up to that given sum, and return those two numbers in an array. So far, do those
instructions
make sense? I know I kind of butchered the explanation a little bit.
I think this is wrong, right? Because the sample output is like
So,
like
10,
-11.
yeah, so
11 and minus 1.
did I copy these numbers? I think did I
Now we're doing the
copy
two
wrong
number sum
numbers?
problem or subsequence.
Yeah, I was like, wait, what am I copying?
Yeah, you
I think I copied from the wrong place a
one.
couple of times. I was like, this doesn't look right. This is not what I was working on.
Oh my god.
Oh, okay. I think that's a different one. Yeah.
Okay, so let's just
Yeah.
do something like that. That's a little bit better.
Mm-hmm.
And then your prompt is wrong too, right?
No. Wait.
Yeah,
Is the
your
prompt wrong?
prompt is the second question. Where are two non-sum?
Oh, wait.
Hey, you
I
replace
copied
with
the whole wrong thing? Oh, Lord. Oh,
yeah.
okay, so
That's okay. Yeah.
this is what happens. That's yeah. Okay. That's much better.
Yeah. I can explain the thought process if you guys want me explain, you know. Uh, it,
Yeah, sure.
Otherwise, we write answer, you're gonna be 10 minutes, then finished.
Sure, go ahead. I would like to hear what
Yeah.
you think about
Yeah.
it,
Go
how
ahead.
to
Yeah.
approach it. Yeah.
Yeah.
So what's the thought process behind this?
Okay, because I just studied a little bit before our meeting. Based on
Mhm.
Algo experts, there are like three solutions, three approaches, and each of them has different, the bigger O. So the first one is, but each bigger O is evaluate like a different scenario or situation. So the first one, time complexity is quite high, and you, you like, because this is our first session, I don't really know, like, do we need to do three solutions, or we just need to do one solution as long as it works?
Um, we can maybe do two, like just like the absolute worst case, and then maybe the best case after. But
Yeah. I
we
think
could just
actually,
kind of
yeah.
explain each one. We don't have to necessarily walk through all three of them.
Uh,
Mhm.
so one is the worst case, like the time complex is quite long, which loop two times. Then the second solution use hash table, which make uh, uh, time complexity better, but space complexity for two times than the first solution. Then the third one is the space, the time complexity better than the second solution, slower than second solution, but faster than first solution. Then the space complexity is better than second solution. So I don't know if I need to talk about this or not. You know.
Well,
Uh,
well, first of all, I'm just gonna ask: does everyone understand Big O more or less as far as time and space complexity? Like what those like
The
the
highest number of
concept?
time. Yeah.
Yeah. I think. Yeah.
Yeah.
I think I have a mix. I think time is like how fast we want it to run. Right. They want it to be the fastest time possible, and what space and complexity, if I remember correctly, it's try to use as little space as possible, right? It's
Yeah,
optimize both time and space, right?
yeah. So time complexity is just basically based on the number of inputs we get. How uh, how long is the time to solve the problem in proportion to the number of inputs? Uh, that's kind of the simplest I could explain it, I guess, without going into too much detail. But if it grows evenly based on the length, if the time increases at a constant rate, it's O of n. I mean, if it increases in a consistent slope, it's O of n. If it's the same exact time, no matter how many inputs, it's O of 1. And then anything beyond that, you get kind of n log n's and n squareds and things like that. And space complexity is any additional space we need to solve the problem outside of the stuff we're given. So if we need any other additional variables, that would potentially be O of n, depending on what we're storing in those variables. Um, so if we need to like make a copy of an array, for example, that would be space complexity would be O of n.
Okay. Okay. Yeah. Yeah. I think that makes sense. Yeah.
Yeah.
okay, so how we gonna do this problem? Um, with, like, the first one is loop two times.
Yes.
Um, and the second one is hash table. Third one is pointer system. Which one do you want me, like?
And seems like I did using two loops.
Yes, that's almost always the solution. There's all any question they give you, you can almost always be solved with multiple loops, which is also like the worst thing, the last thing you want to do.
Yeah,
Most
yeah, that's the
it's
worst
going
worst
to take a
case
lot of
scenario
time.
or the worst. Yeah, the longest way. Yeah.
I'm not gonna lie, even I panicked in my interview and used like two loops. And I was like, "Wait, there's another way." You're the first
Okay.
interview of the day, and I'm tired. I just need more time.
Oh no, that's okay.
So,
Okay.
like, we can more or less explain it. Oh, I don't have. Uh,
You can. I have a README file if you need to make a note. It's in the to some now, so you can do like like this. Then you make pointer system or however you wanna explain
oh, okay.
in the notes. Yeah, and
Okay.
I can help you explain.
Okay. So,
Yeah.
I guess we can explain the. I don't want to explain too much the two loop solution, but basically, as you can tell, we'll have the outer array. Uh, no, or the outer loop, rather, which will be comparing I, and then we'll have the inner loop, whatever, J, and basically for each element in the outer loop. Oh, what's going on? Am I doing something? I don't even know. Each element in the outer loop.
Can you guys see?
Yeah, yeah.
Yeah, we can.
Okay.
Yeah, my wrapping is weird. I got like two things open. But for each element in the outer loop, we're going to compare the entire array. So, in this case, oh yeah, that's so much. Thank you for all that switching.
Oh, sorry. I
No, it's
wanna
fine.
I wanna paste this so people know.
Yeah, paste whatever you need to paste. I'm
Yeah.
just talking. Basically, we're
Yeah,
going to compare the
are
whole
we
array
recording
twice.
this? Are we recording this?
Ah,
Are we recording this?
I
I don't think
am, but
Call?
I don't. But it doesn't need to
Google
be
Meet
shared.
Google Meet don't have a recording unless you want a recording on your own computer, you know.
I'm recording on my local
Can anyone
computer.
record? Because I
Um,
have just 4% on my chart on my phone.
Oh dear.
You can get a charger.
And as I said, electricity, light is not here.
Uh,
Okay, whatever.
So
do
it
what you
will be
need
better
to
if you could
do.
just.
I
Yeah.
do have a recording. It's whether or not anyone wants it to be shared is the thing. But I am recording.
Yeah, I will. Yeah, okay. I will just DM you for the video.
Okay.
Yeah.
Okay,
Oh,
go
Okay.
ahead.
so you're recording, Devin?
I'm recording on my local computer.
Okay, that will be very
Okay,
fine.
yeah. Okay,
Yeah.
cool.
Okay. So, oh, what are we here? And each element in the outer loop. Oh yeah, we're going to compare the entire ugh, entire array. So that's all the notes for that. So basically, every time we get a new I, we're gonna compare the entire array to it, and this is why it's n squared, because we have to go through everything quadratically. I'm not gonna get into all the math, but in this case we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers, so that means we're gonna have to compare numbers about 64 times, which is not ideal. just,
Yeah.
just for quick reference, as soon as the number like goes into double digits, it's your computers and your server is going to hate you. So, for this solution, we're gonna
You
have.
need to jump to here? Okay. Oh, you let me know if we need to jump to the other tab, diving.
Oh, okay.
Yeah.
I think we should be okay.
Okay.
I try not when I have time. I try not to write the bubble sort solution or the loop and loop solution. So I'm like gonna copy this from them. But so basically we're going to have our outer array.
Or maybe you can say then I write code. Like one navigator, one driver. But
So do you wanna? How do you wanna do it? You want me to just talk and then like you kind of write it out?
yeah, so I gonna play like a dumbass didn't know a thing. Then you tell me what to do.
Okay.
Otherwise, we don't need the driver navigate. The just do everything.
Okay. It's not my choice of words, but let's do that. So Jennifer, we're gonna create a loop. We're just gonna loop over the
Okay, can you move
example
your
array.
cursor to another line?
Oh, I'll just move it out the
Yeah.
way. Yeah.
Otherwise, I cannot type. Do you guys can see? So
Yeah.
Yeah, we can.
Yeah, I can see it.
wait, you what? Navigator, please give me instruction.
Oh, I thought you were asking. Oh, I thought you were asking them, not me. I'm sorry.
Oh no, yeah. We asking?
So, first of all, I guess does anyone know this approach as far as like a nested loop? Well, I'm just gonna tell Jennifer what to do. So Jennifer,
Yeah.
gonna write.
Okay, so everybody, so what should I do first?
Yeah. Start with the for loop. You want to loop the entire array. So
We change navigator now.
I thought you were Wait, no, I thought you were. Which one? Which one does the typing? I thought that was you.
Okay, you are I'm driver.
Your driver.
You tell me and I type. Then next solution I can explain. Then you type.
Oh, okay. All right, let's do that. So,
Yeah.
so we're gonna create a for loop, Jennifer,
Okay, for loop.
and we're gonna loop over just the entire array.
Okay, y equals 0, then smaller than array dot length, right?
Yeah. Yes. Oh,
Semicolon.
you need semicolons.
Oh
so,
yeah, forgot.
Okay. So we're going to loop over this entire array,
Yeah.
which is so much fun. And just to make it a little bit more readable, because array I and j is going to get really hard to read really quickly, and then kind of create a variable for each number, or for each element in the loop we're in.
Okay, so I'm gonna create a var. What do you want me name?
We could just have it like first number, second number, or element 1, element 2, just something to tell them apart.
So element good array at I.
Yes.
So that is intermediate variable, right?
Yes. And then
Okay.
we're going to create our second loop.
Second loop. Okay, so
Yes.
that was 1.1, then that will be 2.0. Second loop.
I love this note notation. That sounds redundant, but I love how you got like 2.0, 2.1. It's very educational.
Second, the inner loop, right? Inner
Yes. The inner loop.
loop J, right? Loop through J.
Oh, his phone must have died.
So I just gonna.
oh, his phone died. Oh. What is it? That's the thing. Well, what happened to him?
Am I right? J smaller than array dot.
Yes.
What
It should be
is-
this. It should be. So j equals Well, j equals I in this case, because we're gonna. And then the same thing, if it's less than array.length, we're gonna go up one.
Then J plus plus.
Yes. Alright.
Sorry. What's wrong with that?
The another semicolon. You need the semicolon instead of the comma.
Oh yeah, yeah,
Yeah.
comma, something. Yeah.
Okay. And what should I do next?
Okay, so now that we have it in the loop, we're gonna again create a second counter variable for array of j.
Okay, create a second counter
Our
variable.
pointer, or however it's you want to call it. I'm not familiar with all the terminology all the time.
I think this is called the intermediate variable.
Yeah.
Okay. What do you want me name it?
We could just call it LE2.
Okay.
I mean, we don't have to get overly fancy. LE second.
Otherwise, the number sometimes.
LE Junior, like I don't know.
So that will be array J, right?
Yes.
Okay.
And basically, oh, sorry. So basically, each time the outer loop runs, just to kind of explain what's going on, the outer loop is going to run, and as soon as the outer loop runs, we're going to save this outer loop variable, and then we immediately start on the inner loop. So on the outer loop, we're on index 0, the inner loop starts, and then the inner loop is going to map over the whole array. If the inner loop doesn't find whatever conditions we're about to set, then it jumps back to the outer loop, and we move over one index, and then we start another inner loop with that index, and then map over the entire array again. Or a little bit less than the entire array, because j is going to be equal to I in this case.
Okay, would you mind to type what you just said here as notes? Because people do not really completely understand.
Okay.
Yeah, thank you. Remember, I'm dumbass.
No.
No negativity.
You're very smart. You're just slightly confused at this exact point in time until we solve the problem.
Explain like every little detail to deeper understanding the question, you know.
Okay. The inner loop run. This inner loop will iterate over the entire array if we don't find a target number by the time the loop ends. We then jump back to the outer loop and start the process again. Okay. So that's basically it. We're gonna go everything through the inner loop, and we're gonna compare all of our elements, and if we can't find a match or a sum that equals the target sum, we're just gonna continue with the outer loop. Otherwise, we're going to return the numbers we are looking for and then exit the loop. Okay. So are you going to be typing again, Jennifer?
Yeah.
Oh, let me move my thing out the way then. Okay. So in this inner loop, we're basically going to be comparing whether or not the first number plus the second number is equal to our target sum.
Okay. Whether the what? Can you say it one more time?
Whether our
Oh, you mean the var?
Yeah, I was like, how am I explaining it? We're going to compare
L
our,
at
Oh, var L, yeah. The first
yeah,
yeah.
we're gonna
plus
compare if L and L2, L second. If we
uh-huh.
gotta,
Oh, you got it.
we're going to
It's
check if those equal the target sum. I don't know how to word that.
target sum. Yeah, okay. So that is the logic. So I just gonna if or just
Yeah, you could just
do
do
it
it if.
if L plus like this
Yeah.
Yeah.
Else. Yeah.
equals no it's this right? Like,
No, you can use triple equals.
okay.
Yeah. What was the difference again? Using triple and double? Like,
Um,
Um
double checks if the value is the same. Triple checks if the value and type is the same. But since we're using only numbers, it's just easier, safer to use triple equals. Because we know it's always going to be a number.
oh, the bigger number. Okay. So
Yeah.
it checks with both the
Yeah.
everything and the
These are
type.
kind of questions you would like asking if you like if because the way the problem is explained, we know that everything in the array and our target sum is going to be a number. We're just assuming that all those things are going to be valid. And because of that, we don't need to do like a parse int. We don't need to like worry about conversion or anything. We just have to worry about the actual number.
Okay. Okay. All right. All right. Thank you.
so it's check the value and the data type.
Yes.
Oh, it checks the value and data type. And
Yeah.
that
Yeah.
both
And
the
just
data type.
one equal just value. Oh no, double equal value. One equal is assignment operator.
Correct. So
And the
if
triple.
you do the single equal, technically it would always be true because like you're basically assigning a variable, and assigning a variable is true. So you wouldn't want to do that. But that's not something you need to necessarily remember at this point in time. just know that you need to use double or triple to compare.
Okay.
So
Keep that in mind. Yeah.
so if this equation works, then
Yeah.
we're just gonna what return.
Oh, so you're asking me again. I keep forgetting.
Yeah.
So basically, the condition, if the first number and the second number is, the first plus the second is equal to our target sum, to solve this equation properly, we need to return an array with both numbers. So we would return an array with the values of both, in this case, Ellie and Ellie the second, or Ellie second.
Okay.
Do I need to create an empty array or just do like this?
So you can literally just do that to meet the requirements.
Okay.
And then, okay, so a quick explanation of this. Oh, and lastly, if there is no number outside of all these loops, we would just return an empty array. So
Okay, outside of the loop, right? Outside
of both of them, outside of both
Okay,
loops.
so that was line 28, so we will be written here.
I know there's so many. I was like the last one, but not the There, just return an empty array.
Okay, empty array.
So,
Okay.
oh yeah, just to explain. So as we mentioned, if the first element and the second, we add the first element, we add the second element. If that math adds up to the target sum, we return both of those elements in an array, and the return statement exits the function. There's no more inner loop. There's no more outer loop. It'll return that, and that will be our answer. So we don't need to continue looping or anything like that. But if we go through all of the values, finish both loops, and we can't find anything, Then, outside of both of those loops is our worst case scenario. We return an empty array because there are no
Okay.
matches.
Okay. Do I need to add a parenthesis on line 40? Like
Oh,
do like
you do not because well, basically no, but it helps for readability, just to be sure. So I don't
Yeah.
mind if you leave them there.
because I heard about this is like when you have a lot of operator, this got like a precedent, like this will calculate first, then the other, you know.
Yeah, usually whatever is on when we're doing comparisons, it usually tries to evaluate everything on the on one side first, and since it's just math, it will know to add them. But yeah, in some cases it gets weird, but so we can just leave the parentheses. But in this case, it's not necessary.
Okay. So what should we do next? Should we do the bigger O now?
Oh, define the big O notation, or
Yeah, bigger no notation.
okay, we can do
Where
that.
you write.
Oh, okay. Even the time complexity.
Yes.
Yeah.
So for let's see, should I be asking this or why am I so confused? Like let's ask let's ask Awad, what do you think the complexity is for the time complexity is for this?
Okay.
Okay.
Average case, I guess.
Okay. So let's see. So yeah, I
Or
think.
worst case scenario rather.
Oh, sure. Yeah. Um.
I gonna write. Can you move your cursor? Okay, that's fine. I gonna write here. Bigger O explain.
Okay.
Really no. Okay, so who gonna explain?
Okay. So as right now we have two nested for loops. So so if I remember correctly regarding or then if we're so yeah, I think the idea is we're trying to iterate to every value, and then we try to compare each value if both of those values add to the target sum, and if they do add to the target sum, we want to return the array. If they don't, then we want to return an empty array. Then we want to iterate through the same process. So since we're using two nested for loops, I think that it would not be a linear time complexity because we're not going through the array once. Like I think if we're going through array once, and then that'll be a whole event. But since we're doing two nested for loops, my guess would be it would be an O event squared, if if I'm not mistaken. So that's my guess at least. So since we're doing two nested for loops, and since
So
we're comparing each.
Don't be
square, right?
nervous. Spoiler alert, you're correct. Um,
Oh, okay. Okay.
pretty
I mean,
much.
I guess it's been about a couple of months I've done algorithms. Like I've been practicing more on React, so I was trying to remember.
Oh no,
Can
I understand.
you
It's
hear
hard to
me?
switch gears.
Yeah.
Do you
Um.
need this?
Yeah. Yeah.
Oh,
Yeah,
That's
that's
it.
how you write it.
okay.
And yes, pretty much any time you see one loop inside of another, the worst case is going to be O(n) squared. There are some exceptions where nested for loops are not O(n) squared. You know, if you have certain conditions inside of it to break out of the loop, but it's kind of rare. So you can pretty much assume for every nested loop, it's going to be another. It's going to be +1 on the square factor.
So we had like a nested for loop and we break out of it. That is not all events squared, right? Is that what you're saying?
Yes, there are cases where if you know you're not going to finish the second loop all the time, then it could be like an n times log n or something less than n squared. But for the most part, if you just count the number of nested loops, that's how much n is exponentially. So if there were 3 nested loops, it'd be on cubed or on to the third, and so on and so forth. That's pretty much going to be a rule of thumb to remember. So if, in case you ever forget that, at least know that like you see a loop inside another loop, it's your safest bet is on squared.
Okay. All right, yeah, that makes sense. Okay.
Yeah, it's the other ones you have to worry about.
Okay.
Explain space complexity.
Sure. Yeah. Space complexity.
So just a quick refresher: space complexity is any additional space we use to solve this function. So, for example, the function takes an array, but the array and the target sum variables do not count towards space complexity because those are given to us elsewhere. It's whatever variables we create.
Okay.
Can you
Yeah.
give
Right,
the one example?
Sorry.
Davin, can you give the example of what you just said?
Okay.
Yeah,
So,
maybe in the notes. Yeah.
let's see how I write that. Space complexity only counts for variables that we create inside of our function. And I guess, what in the world? Like, I hate when there's autocomplete inside the comments. Like, I did not need that. And I guess another hint is, space complexity is based on how the size of our declared variables grows, based on the function arguments given. So, to kind of further explain that, it's based on the again, like I said, the variables that we declare in the function, and also whether or not those variables get bigger based on the size of our array. So we've already determined that like the array is O(n) squared because every time we go through an array, the worst case scenario is we're gonna have to loop through that array squared. So like we have now 8 elements, is we have to loop through it 64 times worst case. If there's 12 elements, it'd be 144 times worst case. Space complexity is how much our variable grows. So if we're saving an array, if we were duplicating an array inside of our for loop, the same methods would apply, but not necessarily if we're just declaring static values. You know, strings and maybe strings and numbers and things like that. So, with that information, what do you think is our space complexity?
Oh, okay, sure. Yeah, but before I take a stab at it, just want to make sure I understand it. So let's say we had an input array of n values, and then if we had like an output of n values which is the same size as the input array, would that space complexity be O of n? Since we've seen the same amount of space to store n values from.
If we were storing a copy of the array, then yes, it would be.
Okay.
If we don't store a copy of the array and we just use what's passed in, then it doesn't count towards space complexity.
So
Okay.
what you think I should put in this award? What do you
Okay.
think?
So
This?
in this case, we're not returning a copy of the array. I think all we're doing is trying to find two values that add up to the target sum, and then we want to store those two values into into its own array. So in this case, I think and again maybe Devin, you can correct me if I'm wrong, but I think it'll probably be over one, maybe over one.
Bingo, you are right.
You are
Okay.
correct. I mean, I believed in you, but I wasn't sure because you were kind of nervous. But no, you are correct.
Yeah, no, I was trying to remember because it's been a couple of months, so I was trying to like
Yeah,
Because
refresh my
I
memory.
think if an example, this is not one. For example, like this function, if we use create a hash table, which through the like we loop through the array once only, then we're gonna find the, for example, this that then is it add up equal to target sum. If not, we're gonna throw the element in a like a hash table. Then that will be two. This one will be two because the space we created the extra array, right?
so you're saying, for example, because one of the solutions when I first solved it, I used a hash table. So, for example, if we use the hash table to solve this problem, we basically need to save a duplicate of the information in another format. So we have 8 numbers in an array, and we need to resave those 8 numbers into a hash. That would be O of n space complexity, because we need to store those numbers again to do what we need to do to solve the problem. Whereas in this solution, as bad as the time complexity is, we only use 2 variables. And those 2 variables,
Right.
and whether the array is 1 or 100 elements, we're just using those 2 variables, and those 2 variables are numbers. Numbers don't grow in size like that.
Right. So
It's more or less, the computer saves the number 1 the same as it saves the number 1 million. More or less. It's not Java, we're not getting into ints and big ints. So we could assume that our space complexity is going to stay the same because we're always going to store just those 2 numbers. And we don't even need to store those if necessary. We don't need any space complexity if we omit those, but it's just for readability purposes, really. So in this case, it is O of 1. It's space is not affected.
and I think they probably wanted us to store it in an array, right? I think wanted to return an array of two values.
That would
If
you usually
think-
want to find a balance, basically, between time and space, and
Right.
it's usually easier if you need to choose between one or the other. Well, you want to find a balance, but if you had to choose, it's always easier to get more space than it is to get more processing power. If you had to, but in this case, if time and space complexity were O of n, that's going to be far more ideal than a time complexity of n squared, and you don't use any space or any storage.
Oh yeah, that makes sense because you want to get the best for both, so you don't want to
Yeah,
trade off. I mean, you want to try to optimize both, so to the best you can. Yeah.
because again, like simple mathematics, if we have to loop through the array 64 times, and our space complexity is 1, that's still 64 computations or evaluations, equations, whatever that we have to go through. Whereas, time complexity and space complexity are both 1. You kind of add those together. So, we need 8 computations for time, 8 loops, and 8 more or less computations for space, hypothetically. It's not exactly how the math works, but you see it's much easier math wise. You only have to do a little bit for time and a little bit for space versus a lopsided amount of time for no space.
Okay, I gonna go
Yeah,
rest
go through the go.
back for a little bit, like 1 minute or a couple seconds.
Okay,
Okay,
so
yeah, yeah. Go ahead.
You
I
guys
guess we could just
continue.
prepare the next the proper solution. I guess.
Um, yeah. So,
What
well,
solution did you want to do?
I wanna do the pointer solution, but
Okay,
Pointer solution.
pointer, not a hash table.
not the hash table. Okay.
Yeah. So, let me just run this one quickly here,
Okay. Yeah.
and see if it passed or not. Submit code.
What did we miss?
One of the four tests. Uh,
Ooh, which one did
waiting to
we?
debug now.
Ooh.
Oh,
Oh, whoops. I forgot something. Yeah, it's j is equal to I plus 1. I forgot that.
okay. I gonna use the restroom very quickly, and then you maybe debug a little bit.
Okay.
I+1.
Yes, because I was like, whoops, I forgot that part. So, and the inner loop, we don't want to loop over this. We don't need to loop over the same index twice. So I is going to equal. We start from 0, and then j is going to start from 1, and it's going to stay
Hmm.
that way. So wherever j is always going to be 1 to the right of I in this case. So
Oh, okay. So, yeah.
like
Okay.
in this I have to look on that. I don't. Okay, I can't control like the scroll position. I don't think on her screen. But um, in our example, like we start with the number 3 in our loop.
Mhm.
I would be 3, and then j would equal 5, and then we would start the loop again. I would equal 5, and then j would equal the number next to it, which is like -4, or so on and so forth. So that was the problem. If we I should j should not be equal to I. It should have been equal to I plus 1.
Oh, that's because we don't want to loop it at the same number, right?
Yeah, we
Like
don't want to. We don't want to be comparing the same number.
Oh, okay. 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 Yeah.
Should we run it again? Then
Yes, you can.
okay. Okay. Okay.
Oh, there you go.
Ta-da.
That's nice. Okay, wait. So they allow us to do multiple. Okay, I can explain the second solution quickly. Then I gonna navigate Debian to write a code.
Okay. Yeah.
So this is the plan.
Yes, navigate me because I'm like I don't use pointers all that often. It's the one I have to think about the most. Let's put it that way.
Yeah. So I don't know exactly the approach, but I would call this one pointer solution. Pointer system solution.
Oh. Well, what exactly do we mean by pointers?
So that is okay. So I can give you example. Hold on a second. Let me copy this one. Um,
Yeah, I actually tried to solve it this way initially and was like, I don't have time to solve it this way. I'm gonna just go with what I know.
Right. Right.
explanations type. Okay. Um so basically the thought process is
Mhm.
um this array is sorted, right? can we assume this is sorted array?
Yeah, that's what we have to do. That's the first thing we have to do. That's all the way it works. Otherwise, because when we sort it, we don't have to worry about missing numbers versus if everything's random.
Doesn't matter sorted or not sorted, the point system will work. So we will initial a left, I will say left pointer. Left pointer is hold on. What should I say? So we will initial a number left and a number. Okay, I don't know how to do that stuff. So this is left. This left, this right. So we and you can see the left to right is start with index 0 to the last index number, which is array dot length minus 1. This is the index of last element. Do you guys agree?
Yes. So, you're saying array dot length minus 1.
Yeah. So I would say how we initiate the left point, which is this element, to model the pointer system. Yes, we just gonna initial a left point 0. So 0 represents the first element at the very left. But how can we identify? We by say the index is 0, so that is the very left one. Then we're gonna initiate the right pointer element, which is the very right one, right? So that will be index will be array dot length minus 1. So
Okay.
that is how we represent the left and the right. Otherwise, how can you represent the left and the right? Because
Yeah.
with
Okay.
different elements. So you represent by index. Okay, so we got that one. So once we have left and the right pointer, then we can start. Like the idea is left and the right. Then we compare. Then we move. So this is the core thought process. So how we gonna do it? How we gonna do it? Yes, we're gonna compare intermediate. We're gonna compare. So we're gonna compare left number plus right number. Yes, it's equal to target number. Okay. For example, so the idea is left number plus I'm a little nervous. Right number is it equal to target number. So the target sum is the number, right? So I just write target number. Target number.
Mhm.
Okay, so for example, we're gonna run. So this one we only need a loop one time. Don't need a loop 2 times like the first solution. So for example, the first left number is 3, and the second then first right number is 6, right?
Right. Yeah.
So the idea is that is 9. So we're gonna compare with 9 and 10. So 9 is smaller than 10. Sorry, 9 is smaller than, I don't know how to do that one smaller. Okay, 9 is
Yeah.
smaller than 10. So what do you mean? So the thing is, this is sorted we will assume this is sorted array, and the first step is we need to make the array sorted. So this is left, this is right. Uh, no. Hold on, let me see. No. Sorry. I got it wrong. We don't need to be sorted array. Um,
Oh,
so the thing is, the left one, is the smallest. Then the right one is the largest in terms of the index number. So so if this one and that one sum is smaller than target number, so we need to move. So we need to make this ideal model greater, right? We need a bigger number. We need a bigger number. Because here is 10, now is 9. We need a bigger number. So we just keep the right one and move to the left one to one index. So when we move one index, means index 1, so it will be 5 plus 6, so that will be 11. Then we compare 11 with 10, so that will be bigger. So if it's bigger bigger than 10, then we need to a smaller number. I think maybe we need to sort it. Hold on.
yeah, I think I started that.
Sample input is different from the question I have.
Wait a
Look,
minute.
hold on. That's why. Uh?
Okay.
Oh, so maybe every time we refresh the prompt, array changed.
Possibly.
Because before that one is 11.
Oh yeah, so it's a different array now.
Oh, okay. So
Yeah, so the answer could be in any order. I think is what
Yes,
they mean by that.
so we need a sorted array. I'm sorry about that. We need
Yeah.
a sorted array. That is must. Otherwise, it will not work. This method.
Yeah,
So
you
we
could skip over
Do we have to
numbers.
sort it first, or do we assume that it's sorted?
We have
Yeah,
to
so-
sort it.
Oh, we have to sort it.
In this case, it's unsorted, so we have to sort it first.
Okay.
yeah, sorted is requirement for this one. Okay, now it works. Because if it's not sorted, how do you know the very left one is the smallest one, very right one is the largest one? You know?
Yeah, it would be more difficult to.
Yeah. So we
There's a
need
chance
to-
you could skip over numbers if it's not sorted because
Right,
the solution
yeah.
you need, like the math, while it's doing the math, it may just happen to skip over it looking for a
Yeah,
larger and
going the
smaller.
wrong way. So
Okay, so first, can I continue? First is loop. Just the left one is -4, then the right one is 11. Then that is 11 minus that is 7, right? Then we're gonna compare. With 10. Compare with 10. So that means we need bigger number to make the 7 equal to 10. So so we're gonna, for us to make the number bigger, because the right one already the largest one. Then for how can we make 7 become 10, which is we increase the value from the smaller number. So we're gonna move the smaller number to next one and see if it's equal to 10. So that will be -1 plus 11. So that is 10. Oh, that's already 10? Okay, hold on.
Yeah. Yeah, you solved it.
It should be, yeah. If it's sorted, that's pretty much how it should go.
Oh, yeah, sorry, I'm beginner. I need to think a little bit. So first we're gonna see negative plus 11, 7. Then we need to um point to the left. Uh, why we need to move pointer to the left? Okay, so that one. Uh, okay, we move. Do you guys can help me? I am stuck now. Okay, I gonna look at my notes.
So you're asking why move the pointer to the left from when? From what point?
Uh, so uh, so first way is the left one is -4, right one is 11, right?
Correct.
Then this is right, 7 smaller than 10. Then we need a bigger number. So
Correct.
how we gonna need a bigger number? We move the right cursor to left or
We
the
move the left cursor to the
Left to
right.
the right. Yeah. Yeah.
so
So
we need to
we're
move
starting
from
on each end. I'm pointing. You can't see where my hands are, but we're like, wait, do I have a cursor here? Oh no, you're on the notes. Can I? Is this da da da? Oh, you can't see my
yeah yeah
cursor. Okay.
yeah nice yeah
So we start on each end. Left equals -4. Right equals
yeah
11. Oh, I can't do the duplicate cursor. That's fine. But
yeah
left equals -4, and then right equals 11.
yeah
When and we add those two numbers together, and we get 7, because negative plus a
yeah
positive, all that math, algebra class. And because of that, our our current sum is less than our target sum. And because the numbers are sorted from least to greatest, we need a bigger number. So
yeah
to get a bigger, there is no number bigger than 11. So we can't get a bigger number than that. But we can get a bigger number than -4, because it's our smallest number. So to get a bigger number than -4, we move our left pointer 1 to the right, or in this our left plus plus, and that moves our pointer over, and then the loop starts over again, and now we're comparing our left pointer, which is -1, to our right pointer, which is 11, or we're adding them. In case I missed it, we're adding those two pointers together, and
so
with
wait
that we get 10.
oh, okay. So we finished this solution, right?
I mean, we technically
Yeah.
have to code it, but yeah.
I mean, we have the pseudocode.
Oh wait, now because it's better solution. Uh, equal. Oh, I know why. Because I see another example which is more complicated. Then for this scenario, yeah, we finished. So the number is -1 and 11.
There's a more complicated solution.
No, I think yes, I saw the algo expert. They give an example to more explain this pointer system. Yes, they make the array become okay. Hold on, become like 13. Yeah. So they make this 11 become 13. Then they make 11 become 13. Then they are target array. So for example here, sample output is -1 and 11, right? So they make a target sample. They make a sample output is they make a sample output 8 and 5.
Oh, based on the um
Okay, so that's yes, they make it also this is still same, but the target sum, sorry, target sum is 13. Target sum is 13. Then they make the sample output yes 8 and 5.
Right. Yeah.
Okay,
So
so
that
you're okay.
will not finish in 2 steps. So I got with the so if the one just like this question, then the 2 step way down. Only loop one time. That is the better optimized solution. So do we want to try this one too? Target sum 13, then sample output is 8 and 5.
I didn't
Okay.
see that. I didn't see that that example, or I don't see that example. I think it just generates different numbers because I'm like, where is 13? But
No, I think this is the same question, but extended, like extended example.
oh,
So
okay.
the question is still -4 to 11, but the target sum is 13 and the sample output is 8 and 5.
We can do that.
Yeah. So, but if we do that, then our thought process will not just 2 steps. It's gonna be like 1, 2, 3, 4, 5 steps. Do you guys wanna do or no? So we can get a better understand the more complicated pointer system.
Oh, so you want a more complicated pointer system? I see.
More complicated pointer system.
It's up to you. You're the one. You're the navigator.
Navigation has big moments. Actually the one I just explained it's right. It's just -1 and 11 because it just happened only step like this and we got solution. So if we do the example for 8 and 5 and the target is 13, we're gonna comment out this one. So this is target sum is 13, sample output is 8. So we're gonna change here. Example 2. Um, 2. So it will be this still the same. LP and RP still the same. Then the tag. So this is the sort process. It's the same. So the example will be first one. Example. So first number is 4, right? Very left one. Okay, we're gonna put this here. We're gonna put this right here. Put we're gonna put right here. Okay. You guys can see. So the first number is -4. Then the right number is 11. So that was 7. Then we're gonna compare with 13 because the target sum number is 13 now. So that is that means we need a bigger number. Bigger number. So if we need a bigger number because the right already the largest number, in order for us to get a bigger number, we're gonna move our cursor from left to right by 1. So it will become, so the left num become -1. And the right num still right, still the 11, then that will be -1 plus 11. That is 10, right? So we're gonna compare 10. Is it equal to 13? So that is smaller than 13. Uh, Smaller than 13, then we need a bigger number. So I just gonna write bigger now. Um, so we're gonna move our cursor from left to right to get a bigger number. So now the left now is become 1, and the right number become the right number still 11. So you're gonna 1 plus 11 is 12, and compare with 13. So it's smaller. Then we need to bigger. Then we're gonna move again from 1, then become 3. So now left number become 3, and the right number still 11. So right now is 3 plus 11. So now it's 14. So 14 is bigger than 13. Then we need a smaller number. So in order for us to get a smaller number, yes, we just so left number right now is 3. So we need to move the right number to become smaller. So our right number become 8.
Mm-hmm.
Do you guys agree? Cause
Yeah.
Yes. Yes. So since we're at 14, that's bigger than.
yeah. So
Sorry.
what is the left number we are at now?
So let's see. So right now we're pointing at 3, left pointer, right pointer at 11.
So the left is 3. So the right number is 11. We want a smaller. We will move the
The right
right
pointer to the left.
smaller number become 8.
Yeah.
Okay. So now our left number is okay. So wrong. So
11.
we're gonna do left number 3, right? Then right number become 8.
Yes.
So 3 plus 8 is equal to 11, which is smaller than 13. So if smaller than 13, so we want a bigger number. So if we want a bigger number, we're gonna move our left number to right. So what is our left number now? Should it be?
So it should be 5. 5.
Okay, so what is our right number now?
And our right number is still 8. So
Yeah.
okay.
So
So then
so yeah. So our left number is uh
5.
5, and the right number is still 8.
Yeah.
Then we're gonna get 5 plus 8 is 13. Then 13 equals 13. Then down, So that's how it is. Then we're gonna throw these two numbers in the array. And we got answer. So these 5 and 8 is the sample output, 8 and 5. Do you guys agree?
Yeah. Yeah, I do. Yeah.
I
Yeah.
agree. Does it make sense? Just going through the same kind of formula, just a different example. Does that sort of understand what's going on? Like she really walked through it step
Yeah.
by step there.
Yeah, I think I mean, as we were saying, in order to even do the left and I'm sorry, in order to do the left and right pointer, we have to sort the array first, right? Like we have to sort it because if we don't sort it, then it's gonna make it more complicated. Like because we might skip over the correct pair of values that might sum up to the target sum. So
Right.
in order to even start this problem with the left and right pointers, you have to sort the array, right? And then what we're doing here is putting the left pointer to the very left value, and then the right pointer to the very right part of the array. And then we take the sums of those two numbers and compare with the target sum. And as we were saying, if that's less than the target sum, then assuming that we have a sorted array, we'll just move the left pointer one up to the right. And then
And
what was that? Sorry.
so I think the triplet, but he left. He asked me a question about what if the sample output has two, like for example, like this. So what should I do? Should we do? I think because right now for our scenario, only sample output only one, right? So I guess it's just be only one. So if two, we just gonna still doing the pointer system until we find another pair. The sum is 13.
Yes. So in our scenario, in our scenario, our array only has one answer. In this
Mm-hmm.
particular scenario, if there were multiple answers, we'd probably just return the first one we come across. If we needed to save multiple, or as many as possible, we could use. It just depends on the parameters of the question, really, because this same problem could be used to solve for multiple answers. If there were multiple answers to the number 13, this solution could also save those. We just have to tweak it a little bit. But for our particular question, where there is only one example, this would be ideal. So it just depends on the question, and that was good on him to kind of ask that. But for the particulars of this question, we only need to solve for one, and that changes how we write it just a little bit.
Okay, sounds good. So should we implement this in the code? So this is the sort process. So we're gonna do that in the code, right?
Okay.
So solution two. So I gonna be the navigator. Who gonna be the driver? Davian?
I Is anyone else on the boat?
Yeah.
Does it got the keys to the wheel? Looking around like I guess that's me.
Let's drive. Okay. Okay. Are you in the text editor now? Line 683. Okay. So you're gonna write this function first.
Okay.
Function
Oh, I
name.
copied the wrong things. I can't copy that. I forgot.
Yeah.
Right ones. Okay. There we go.
Yeah. Okay. I would say first step is sort the array.
Okay.
Can you also write a pseudocode to like step one, like those notes, because people will forget.
How you
People like will
how you
forget.
do it? 1.0. You had a whole system. I was like, I want to follow that.
Yeah. Okay. Yeah. Then just write the array sort syntax. Yeah.
Oh man, we don't have to write our own array sorter. That's amazing. I love that.
I thought this array got sorted, right? Or we need to write like this?
The array doesn't come sorted, so yeah, we have to sort it like this.
Okay. So it's done.
Yeah, that sorts it in ascending order.
Yeah. Okay, next step is we're gonna initiate left pointer. Just name it left.
Okay.
You need to write the node like 2.0 or
Oh.
something. Yeah.
See, yeah, you gotta remind me your notation system. Um,
Initiate left, yeah, whatever you want to write.
I like
Yeah,
initiate better.
yeah.
Sounds more navigation-y.
Okay. So we need to let it left equals 0 because that is pointer system. We're gonna point the index number, not just the element.
Okay.
And what will be the right? I leave it to you.
It's just gonna point to the end of the array.
Yes. So that will be last index of the element in the array. Great job. Okay. Um, okay. Step 3, we're gonna loop through the array, but using while loop, or can we use for loop?
Hmm. I don't know anything right now, so I don't know. Maybe let's see. We The way you
Maybe,
described it, we have to go through and compare
maybe
everything.
I write pseudo code, then you put in the code. How about that? I write a note, then you put in the code.
Okay, that works.
Yeah. Okay. So I will say while. So that is logic. You can change to for loop or other loop.
Yeah.
While left is smaller than right, then we're gonna do um we're gonna do uh left element plus right element equals intermediate variable. That you can change the naming, okay? So this just for us to understand the intermediate variable. Okay, so that will be that one. I give a name called the current song. So we will compare the current song with the target song to see if we're gonna move the left pointer or right pointer. Uh, current song, and can you okay, this is me. Okay, then once we did that one, then we're gonna conditional check. Conditional check. Uh, conditional check. What should we check?
Hmm.
So we're gonna check if current sum current sum is equal to target sum. Okay, so if it's equal, so if yes, if true, I would say if true, if true, then return. I write here. Then return. What? Return the left element and the right element. Okay. Then another thing is uh, else if else if uh, else if is the what will be else if? Okay, so else if its current sum is smaller than target sum, then we will return. Okay, I write here. This need to be inside. So then um, then we uh will increase left pointer by 1. So the left is the pointer, okay? It's not the left element by 1. Okay. So another thing is, else if current sum are greater than target sum, um, then we will we will increase right
Or
point.
decrease it. Decrease. Right?
No, increase. Wait.
Um,
Because you
the
want
one to the
to.
far right. So technically, we're moving it
Right.
left. I don't know what we call. I guess yeah, we'll be
Because
decreasing
yeah,
it.
well, left, right.
Decrease. Sorry. Decrease.
Okay, yeah, no problem.
Remember, the left pointer is the index number, right pointer is index number 2. So if we move the right pointer to left, means the index number decreased by 1. So I
Right,
may say
right.
left index, it will be easy. Right index.
Oh yeah,
So it
there.
will be decreased because we moved the index to the left. Okay. Then, okay, so after that, another one is else return the empty array. Okay,
Mm-hmm.
so the driver, can you please translate this in code?
Um, okay.
Do you think we can use for loop for that or no?
uh, it's usually I want to, but it sounds like because we gotta move left and right, we can't just go straight through. So we probably have to do a while loop. That's my guess.
Okay, so for loop is just from first one to last one, right? For
Okay.
loop, yeah.
So I guess while the left pointer is less than the right. Okay, I don't gotta type like I don't know anything. Well, left is less than the right pointer. Doot. Doot. Or, yeah, something like that. It's fine. It's just gonna get annoying either way. So, while the left is less than the right pointer, let's see. We need to find the current sum. So, let's see.
So yeah, we establish an intermediate variable. Yeah.
Equal. And these are just indexes, so I need the actual number. So, array left plus array right. Yeah, that index is much easier to remember, yeah, because they are just indexes. So,
Yeah.
we get the first and the last number.
Yes.
Okay. Conditional check. If current sum is equal to the target sum. Simple.
So that will inside the while loop, right? The conditional check.
Yes, everything's inside the while loop.
Okay.
I'll have to indent this later.
Yeah. Don't worry about that.
It's like, I hope I don't get confused. Current sum is equal to target sum, which is what we want. Is it sum? Sure. Then, if true, we return left and the right. Okay. So then we would turn. Oh, it has to be in an array. Because we need to return the numbers. We need to return array left and array right. And the brackets are messed up. Okay.
Yeah.
There we go. And of course that's not, but wait, there's more. Um, oh, right. So, let's put it here. Else if. I never know how to spell else if. I always have to look it up. Because I do it in so many languages and they all
Oh,
spell it
yeah.
differently.
Yeah, like Python is elif or
Yeah.
In PHP, I think it's just one word. It's just else if.
oh, okay, that's one word. Huh?
Yeah, else if. So we see if the current sum is less than the target sum. And if it's less than the target sum, that means our number is too small and we need to make it bigger. Oh, it's giving me bad. Oh dear. I think it's okay. Else if the current sum is less than the target sum, then we need to, like I said, we need to get a bigger number, so we need to move the left one up. And then else if, then we need to check if the number is too big. Current sum is greater than target sum. Then we decrease the right by 1. Okay. And then lastly, if none of that
Return
works, empty array.
Yeah, outside the while loop.
Oh,
Okay.
yeah.
Job.
Oh man, no errors. That's amazing. Let me
Amazing
just.
buffering.
Alright, yeah. No, wait. I need to. There. Yay. Okay.
Okay, cool. Then the hour will be talking about time complexity.
Okay, sure.
Yeah.
Uh,
Okay. Okay, we're gonna put a solution to. Okay, hopefully it will be good.
oh, good.
Oh, good. So
Oh.
we don't need to lock the tests, right? Why those are okay? We can see.
I
Okay,
don't
so
know
it
why
has
the
more.
tests are hidden.
Oh, I didn't know because it has those stuff, the I stuff. Okay.
Yeah, like it's hidden, but it's like it's just tests.
Oh, yeah, that's cases.
It's not like it's the answer, and it's like don't look, don't look. It's
Our
like
solution cover all the test case. Okay, looks good. Okay, so we're gonna talk about time complexity. Um,
this one's kind of tricky.
yeah, since we're
you're gonna do this, and we help you.
okay. Okay, can you go up to the code again, just from the start? Want to make sure that.
Okay, I can copy this, then you revise. How is that?
Okay, yeah, that's
That's cheating. No, I'm kidding.
yeah. So in this case, we're using a sort function, right? To sort the array.
Yes.
So due to that, it has its own time complexity, right? When we use the sorting algorithm.
Aha.
So that means linear, right? Or no?
Or not, or not quite, or
No, I don't think so. Or, yeah, because I remember it has its own.
So what what does it mean, linear or not linear?
I think linear just means like if you're going through the array once, right? So it's not like a nested for loop where it's all red square. I think if you're just iterating through the array once,
Okay, so this has nothing to do sorted or not sorted.
right?
Okay.
So okay, linear is direct proportion to the size of the array, which
Yes.
which I guess it's not quite. So, what do you think?
Hmm.
But I know this is going through array only once, so I can delete a not.
So yeah, not linear.
Yes, it's linear.
What was that? Sorry.
Yeah, so our this solution too is it linear or not linear?
Since we're using the sorting function to sort an array, um, I'm gonna guess it's not linear, or since we're sorting the array first.
Okay.
That's good. Do you know the time complexity to sort of a sort is? Well, I
Yeah,
could
I'm
have.
trying to remember this.
To be fair, if I remember correctly, it uses a quick sort. Not that that's important, but if you remember which uh, time complexities each kind of sort has, then maybe that's a
Right.
hint.
I think. um, I think either it's O of log n or O of n log n, or is it one of those? Or,
Okay. What do you
Oh,
say,
so you are
Navigator?
what
well,
do you
For the
write?
sort.
yeah, I'm just guessing. I'm just because
Right now, he's just guessing the time of the sort. And he says
for
the
sorting,
sort. He says the
sorting
sort is
algorithm.
n log n.
Okay, can
I
you
think
type
it's n log n.
can you revise the notes, Davian? Because I don't know what should we write.
Wait. What line are we? Are you
Line
in?
97. Line 97.
Wait, of the. Oh, I switched files. Okay.
Yeah, in the twosome.js.
Okay. So
So he gonna say you revise, and if he got stuck, you help
okay.
to
I'll
make
just
the revise successful.
sort time. As he says, n log n,
Log n, I think.
and then that's the while loop time.
Oh, so when we do while loop, it will be n log n, right?
Mm. Yeah, well, because we're sorting the array first, right? So I think that because of that, my guess would be O of n log n because we're using a sort method to sort the array first before we even do the while loop. So or before we even iterate through the array. So okay, I think you have to take that into account, the fact that you're sorting the array, and yeah, and as we discussed, I mean, sorting the array has its own time complexity. Um,
Mm-hmm.
but I'm just trying to remember what it was, and I mean, what comes to mind is O of n log n, but if I remember correctly,
For the while loop.
or
I
I'm sorry, for the while loop, it will just be. I think we're going through it once, right? So it'll
Hopefully.
be O of n.
What's the? Yeah. So I guess he says on. Okay. To give you an extra hint, we add those together since one is not inside of the other. We add those together.
Okay. Oh, okay. We are. We're doing both separately, right?
But I thought the question answer time is n like this. This is the answer.
It is the
For the
answer. You spoiled it.
that is the answer. Okay, that is the answer.
This is answer, but I don't understand why we put the n log n.
I just
You
wanted
know.
him to think about it. So, so in big O notation, uh, he didn't need to know all that. We only care about the longest possible time. So,
Okay.
if we added this together, it would technically be. I wasn't gonna do all this, but like she called it out. It would technically O n log n plus n. We don't care about n because it's smaller than n log n,
Oh,
and because of that, we basically round down to like uh
okay, got.
ah round down to just o n log n.
Hmm.
Okay, then
Okay.
that makes sense now. Otherwise, it doesn't make sense. How come this one yes become this one? Now makes sense. So I just gonna remember once it sorted already sorted, then I just put this one. Then wait, while loop I understand just one time. That's why O n. Then because you say this is very smaller, we can ignore. Then we just round down become this one, right?
Yes, because basically we only care about the worst case scenario, and in the worst case of things, n log n is a way bigger. If we're talking, thousands and millions of data sets, n log n is going to be so much bigger than n, or even log of n half of the time, because most of the time we're probably not going to go through the entire while loop. That's the so it's going to be so small it's considered insignificant, so we can exclude it.
Okay.
And and also it's just to point out that the time that it takes to sort the array is completely different from the time it takes us to do the while loop. They're not directly related. The while loop is not going to increase in time. Uh, it's not like the sort algorithm is running our while loop. They're two separate computations. So we only add them together. We don't do any kind of weird multiplication or anything. They're two
Uh,
separate tasks. So you add
Hmm.
them, and because it's the while loop is so much smaller, you focus on the sort, and the sort is n log n.
okay, that's good explanation. See,
Yeah.
other YouTube video, they don't talk about this stuff, you know.
Oh,
Yeah,
they don't.
you gotta go to the books and the cracking the coding interview for all that, because
Bigger O.
in the interview you wouldn't do in most interviews you wouldn't have to do it's O of n log n plus n. You wouldn't have to do that. Maybe in math you might, and if you're doing actual maybe data science, but in big O in terms of computation and stuff, you just focus on the largest loop.
So bigger O will be same for all languages, right? That is for
Yes,
all languages.
Yeah.
Okay.
for
Yeah.
all languages,
Same big.
it's pretty much dependent on this, the size of your data and how long it takes to do whatever you need to do it. And if this would be O n log n times log n, and pretty much this solution would be O n log n in any language, whether it's Python, whether it's Java. There's these. It'd be a very similar solution with a very similar, if not exactly the same, time complexity, just depending on how the language performs.
Okay, sounds good. Okay, Howard, can you continue the space complexity so David can revise the notes?
Mhm.
Where is space time? Oh yes.
So yeah. Yeah, space complexity. I think would still be O of one.
Yeah, you are right. At least I know the answer.
I was about to grill you, like, and why is that?
You can ask why is that our.
Oh yeah, sure. Because we're not making any change. I mean, we're still using the same array to store two values that sum up to the target sum. And although it would technically be O of two, I mean, in computer science that wouldn't really make sense. So because of that, it would just be O of one.
Yeah, it's still constant because it's always going to be two variables that are numbers basically, or
Right.
or they're always gonna the values of the numbers is not going to shrink, or I mean the value will, but in terms of space complexity, you know, the size of the space it takes to store a number, that the memory usage would be the same. I thought
Mhm.
the sort was going to trick you, but since the sort is, since the array is something we get passed in, and not something that, and since we sort the array itself and we don't like create a new array and sort it, it's still, that doesn't get included in our space complexity because we're just sorting the existing array as soon as we get it.
Mhm. Okay.
Uh,
Yeah.
Pretty good. So we pretty much done with this, and I gonna save this and zip the file in the Slack chat, so you guys have all the notes and whatever code. Sounds good.
Yeah, that'll be great. Yeah. Yeah. Thank you, Jennifer.
I will zip it in the our group. Okay. So are you still recording, David? I was gonna talking about, are we gonna do next session? Do you guys like this, or we do too slow or too fast, or you like those deeper walkthrough?
No,
And
I think no. This is good.
and on a
Yeah.
lesser note, there's my solution. That was what I worked out pretty much before this call started, which was the the hash table solution, or a variation of it.
No, yours is not hash table.
Mine is.
No, yours is loop two times
No,
solution.
wait, which one is this? No,
Is this one yours? Yeah.
it's technically, wait, which da. Wait, is this the
Your
working one I had? This may not be the
your
working one.
thing is the loop two times. We
Oh wait,
didn't
that's
do.
not even my working one. But
Yeah,
no, it's not the. I was trying something there. Sorry,
we
but
didn't do hash table today.
this was the hash table, and it's two loops, but they're not nested. So it's that's why it's not n squared. Why is there so
Oh,
many tabs?
oh, so you even did the hash table? That's good, but we didn't explain, but you provide the solution, right?
Yeah, that
Let
was the
me,
one I came up with on my own. It's
uh,
different from the solution that they gave, but it's still a hash table solution.
okay, hash table. I'm gonna write notes. Solution. Okay, that's good.
Okay.
And you guys have answer, right? This hash table solution is O n for time. Uh, then O n for time, then O n for space. So this means space no good, time good. Space. Okay, so this is the answer.
Yeah, it's the quickest time wise, but because you also have to store the array in a hash, it's the biggest space wise.
So hash, you just make a empty object, right?
Basically, to explain this solution really quickly, you make an
Mhm.
empty array, I mean object, hash table, dictionary. It's like 1,000 different names. You know,
Just say hash table emulate.
you make a hash table because we want to sound fancy, like we're in a real, coding interview, and then
Yeah.
we loop over each element, and I make the key I make the object key or the hash key the value that I'm mapping over or looping over, and the value is the pair that it needs to meet the test case or to meet the target sum. So blah blah blah. So for example,
So for each, can we do for loop too?
you
It
could.
works the same, right?
It works the same in a for loop. I just hate writing the whole thing out. It works with a
Yeah.
for loop. It works with a map. It works with a while. Technically, it works with a while.
Okay. So just loop one time, right?
Yes, and it would basically be something like 3, and the value it needs to match to match 10 would be 7, and then it would be 5, 5. -4 is I think 15. No, 14. And
So for
and
each,
everything like that.
okay. So for each is a way of
It's a
loop,
variation
right?
of a for loop. Basically, for each creates a for loop. It gets the length of the array. Like dynamically, you don't have to define how long the loop is. It basically takes the array and loops over each element.
Okay, so in this case, it's looping over
It's
number.
looping over this. It's just gonna loop over the entire array, no matter what.
Oh, the entire array. Okay.
And each element in the array, it's going to create an object with the number as the key. This is the array 3, 5, -4. All these are going to be keys, and then their matches are going to
Can
be
you write
values.
a note here? Like just very quickly. Like what do you do for
You
100?
save the the value of the
So array
number
value
as a key,
Mm-hmm.
and we save the pair we need to reach the target sum as the value. So
Oh,
-4, 14, it'd be 8, 2, 1.
so the key is 3. 7 is the pair, right?
Yes.
Okay.
Technically 1 would be 9, but it still works.
Mm-hmm.
and so on and so forth.
Okay, sounds good.
And then array.filter is a second it's just another looping function. It loops over each element of the array. But
Mm-hmm.
it filters the result based on the condition. I know it's like a complicated condition. But basically we look to see if we check to see if the key exists. That's the first thing we check.
Okay. Can you write notes here? Because
Yes.
people don't forgot. I will
Oh,
easily.
whoops. Where am I at? Oh, yes.
And 11 check what?
See if the numbers object has numbers has a priority target sum minus number. Okay, if our numbers object has a matching, how in the world did I come up with this solution so easily? Now that's the question I'm asking, because it's hard to explain.
Don't memory. Sometimes people memory.
This is just one of those ones that like I could do it and like, oh yeah, this takes like 5 minutes, and then like, how do you explain it? This is weird. I just memorized it. So look at the numbers arbiters to see if it has a matching. Because number has a priority target sum as it has a matching pair. in our numbers object. I should have named these better now. I knew this naming would get in my way. But we check to see if the numbers object has a pair in its index, meaning that basically we look to see if so for example we check if target sum minus number is a key in our oh wait, yeah, I already wrote that. Is a matching pair in an object. This means that the number was in our array. That's why it has to be a key, because all the keys are numbers in the array. So you have to check our keys specifically. And that's why we use the has on property.
Okay, sounds good.
And yeah, and then lastly, we have this check because each number has to be unique. So for
Okay.
example, like
Yes.
two sum number is we're looking for the number 10. 5 should not have 5 and 5 should not be an answer. So we have to make sure that the key and value are different. That's all that means.
Okay.
She wrote that down. So yeah, it could be explained better, but and I'm sure like the way they wrote it is easier. But yeah,
Yeah, coding method so everybody, even me, know how to write.
I'm just gonna like steal their variables, like we store potential match as our value. So num in array potential match.
Okay.
Yeah.
Okay. Yeah.
It's not. I didn't write it to be easy to read, unfortunately. I should have.
I kind of get it. I think I get it. Got up to the for each up to the.
But basically, it works because filter returns an array of everything that meets the conditional, and so if a number equals this and it equals this, then it's gonna return both the number and its match.
Okay, sounds good. If next time we have question, can we go through this solution together? If when we work on our own and still don't really understand.
No problem.
Yeah.
Okay. Okay. Yeah.
So, cause we already over 10, so maybe we're gonna kind of like finish today's session and schedule next section.
Yeah, today's session is definitely over.
So well, when do you want to meet again?
So I have two options. Okay, one option is we go through Algo expert each question very quickly. But we do more. Or we go each question deeply like today, and deeply understand and analysis. Like those.
Yeah.
Like those, but it's kind of like slow. Which one do you prefer? Two options.
What was the first option again?
First option, we just go through, like for example, I just got a prompt, then just write, like one person say, then the other person just write the code.
Oh, okay. No, I think the second option was better, where we go in step-by-step detail.
Okay. Will
Yeah.
it be too slow for you, David?
Oh,
What
yeah. What?
the bubble loop, the the loop in loop?
No, I didn't talk about the solution. I say the options for our meeting, the style
Oh,
of our meeting.
oh,
Yeah.
well, I mean, I don't
Can
know.
you
It depends on the students.
can you repeat my question to David? I
Yeah.
will.
Yeah. So what she was saying was, when we go over the questions, like, would you prefer that we go through them quickly, or would you prefer that we go through them step by step, like how we did now, like how we went step by step? And or like, is that considered too slow for you? Like, would you want to go maybe a little faster on the
Well,
problems? Or
well, it's not necessarily up to me. It's up to, I guess, the students as far as what they can actually learn from it. Because, like,
yeah,
it may be too slow for me, but I was more worried about if it was, like, too fast for anyone watching. Because, like, no one cares if
uh,
it's too slow for me. I'm, like, I'm not, it's not for me
yeah.
necessarily.
I mean, who else is on the call? Like Trupti and Elizabeth, or are there
Potentially
any
more
people?
people. Like it was mostly us three today for the most part, but it's not
Yeah.
always going to be that way. So like
Yeah,
the
we
slower
should add
pace can help
people too.
with for some.
So maybe so for if for beginner, maybe my approach is I gonna watch the videos, whatever, then I gonna write all the pseudo code like this. Then the driver just based on the pseudo code write code. Does it sound good?
That sounds like a
Uh,
good plan. I like
yeah,
that.
yeah,
Okay.
yeah. Yeah.
Okay. But that take a that take a time.
It
Like not take time, like slow pace.
Yeah, I mean, I think it's okay. Maybe to speed it up, maybe we don't need all the solutions, maybe. But I think it's
Okay.
also helpful to see different perspectives. So I don't think
Right.
there's like a
Yeah.
necessarily a rush on any of
Uh,
this.
okay, sounds good. So next time we will keep the same pace, okay?
All right. Just a question. Okay, can you go up to the array sort? Uh, yeah, over
We,
here.
uh,
Yeah. Uh, so I was curious, like when you write array sort, like isn't it like array equals array dot sort, empty parentheses? Like, do we need the A and B, or is that part of the syntax?
So you
Cause I
want
know.
to take this one or should I?
so he asked you if every time we write a result, we just put A and B.
Oh, so
Yeah.
okay, I'll answer that. So basically, the sort function. Um, I'm about to over-explain, but here it goes. The sort function by default sorts by, I believe it's Unicode values, which is
Mhm.
why it's not reliable for sorting numbers because it'll sort 1, 10, 11, 2, 3, 4, 5, 6, which is why it takes a callback function as a parameter. And that's why it has to be a callback function specifically. The callback function, it takes two parameters, which are a and b, and we write a minus b because of the way it handles the callback function. So when it calls the callback function, it takes the two numbers it's sorting internally and it subtracts them. And if it's negative, it'll sort the smallest number first. If it's positive, it'll sort the bigger number first. And then if it's zero, it just won't swap them. So to sort,
Okay.
that's why I wrote ascending order, because a minus b, when we subtract the bigger number by the smaller number, it's going to return a negative. And so because it returns a negative value, it'll, whenever it's negative, it'll put the smaller number first. So this is, I didn't explain it properly, but basically this is how we tell it to sort from smallest to biggest, because it's going to subtract ideally the smallest number a by a bigger number b and return negative, and then return the smaller number first. and when it runs the sort internally, it'll sort it from smallest to
Because,
biggest.
okay. Yeah, I assume that if you sort the array, it would be like, for example, let array equals array dot sort empty parentheses. I thought that's how you sort the array.
Yeah.
No, it just takes a callback function. You can write the function however, but that's basically what it's looking for. And then if you want to look up how it does the sort, then you look up quick sort because that's the kind of sorting that array.sort uses. But
Oh,
and
quick
that's
story.
why
Okay.
it's n log n because quick sort is n log n. So
Okay.
but yeah, the basics of how the sort function works, that's how it works, is like Unix values by default, and then the callback function just works by comparing whichever one returns negative. And that also works for letters because smaller letters have smaller Unicodes than bigger letters. So the same thing hypothetically. But
Okay.
that's it's yeah. I know it's not like this the easiest thing to explain. At least for me. I'll get better at it next week. But that's more or less
Okay,
how it works.
No. Okay. Okay. Yeah, I think that kind of makes sense.
that
Yeah.
sounds good. Okay, so what's the plan for next? Are we gonna meet on Sunday afternoon or evening?
It's up to I mean, I can do Sunday afternoon. I need to just let me know I guess which time to make sure I'm free. But
Okay, well,
Yeah. Same here. Yeah. It's
so you will join to a what too?
yeah, that should be fine. I mean, if like yeah, hopefully it will come up last minute. I
So
think for now that should be fine on my
so
end.
so Sunday we're gonna work on this question. Okay, another one is so for future because I wanna keep this like a routine. So so I think we are slow pace. So every time we just solve one question. So the thing is, do you guys like this easier first or by topic?
Um.
hmm.
Like,
Uh.
do you guys want easier, but the question maybe binary search and like everywhere, so it can be binary search or node, all those stuff. But this is, or we just do array until the blue or red, then we do binary search blue to red. Don't know if I gonna do the black.
Oh, that sounds so much fun. The black.
Yeah. Yeah. What's the BSTs?
Oh yeah.
Because I know because next one doesn't matter which one you're gonna be. This one, it will be that good.
Yeah.
Maybe because some topic I am not really familiar. I need to learn some of them. But array, maybe next time we do array, then next time we do array again. So we just do all the arrays like a hell. Then we move to next topic. Sounds good.
Okay. Yeah.
Sounds good to
Yeah.
me.
I think
Yeah.
that's fine.
Okay. So next time we do this one, then next Friday do this one. Three num song.
Okay. Yeah.
Three num song, same like two num song. Then we can switch roles because people already explained two num song. Then the other people can do three num song. See if they understand the lecture or not.
Okay.
Okay.
Yep.
Yeah.
Yeah, you're
Sounds
gonna do
good.
that next week, aren't you, or what? Yeah, that's all you.
That's all.
You're gonna teach us the
Teach
three num
us three
something.
num song.
Yeah.
See
Okay.
you understand the point system or not.
Understand the point system. Okay.
Yeah. Okay, sounds good. So I gonna end the meeting, or unless you guys have other questions, then I gonna zip the notes and solutions in the chat so everybody have that.
Okay. Yeah. Sounds
Okay.
good. Yep.
Okay. Sounds good, David.
Sounds good to me.
Yep.
Okay. Bye,
All
guys.
right. Take care,
Yeah.
guys. Have a good night.
Yeah.
Later.
Bye.
Bye. And that is it for this recording. And I hope everyone enjoyed it. And we'll see you in the next video.